Imagine a perfectly rigid, hollow sphere resting on a rough horizontal surface. Today, we're going to explore how a sudden horizontal impulse above its center dictates its complex journey from rest to motion. When the impulse strikes, it imparts two things simultaneously: forward linear momentum and clockwise angular momentum. The result is a sphere that begins to both translate across the surface and rotate about its center. Immediately after the hit, the sphere's behavior depends on where it was struck. If the impulse is relatively low, the forward motion of the center outpaces the rotational speed at the point of contact. This causes the bottom of the sphere to slide forward relative to the ground. In this scenario, friction acts in the opposite direction of the slide, backwards. This friction serves a dual purpose. It slows down the forward translation while simultaneously providing a torque that increases the sphere's rotational speed. However, if the impulse is delivered much higher up, the rotation becomes dominant. The bottom of the sphere actually tries to move backward relative to the floor. Consequently, friction acts forward, pushing the sphere's center faster while reining in the excessive spin. There is a unique sweet spot for a hollow sphere, exactly 2/3 of the radius above the center, where the impulse creates the perfect balance. In this case, the sphere enters pure rolling motion instantly, with no sliding and no initial friction required. Regardless of where the impulse was applied, friction is the great equalizer. It will persist until the forward velocity and rotational speed match perfectly. Once this state of pure rolling is achieved, the sphere continues its journey in a stable, harmonious glide.